Some water projects don't just supply resources, they might save our future. Welcome to Top 10 Future Water Projects that could save the planet. Don't forget to like, subscribe, and hit the bell for more groundbreaking innovation content. Let's dive in. From massive desalination plants to futuristic water recycling systems, these projects are tackling the world's growing water crisis head-on. Using cutting-edge technology and bold engineering, they aim to provide clean water, prevent shortages, and protect our planet. Here are the top 10 future water projects that could save the world. 10. The Great Green Wall Hydration Network. The Sahara Desert keeps expanding, endangering communities. The Great Green Wall Hydration Network expands Africa's reforestation project, using solar-powered pumps, underground aquifers, and drip irrigation to fight desertification. By combining modern tech with ancient water conservation methods, it supports agriculture and restores dry lands. This ambitious effort brings hope to water-stressed regions, blending innovation with traditional wisdom for lasting impact. 9. Floating solar desalination islands. Addressing two critical challenges simultaneously, floating solar desalination islands represent an elegant solution to both water scarcity and energy needs. These autonomous platforms combine concentrated solar power with advanced membrane desalination technology. Deployed along coastlines of water-stressed nations, each island produces up to 50,000 cubic meters of fresh water daily, while generating surplus electricity. Unlike traditional plants, these islands produce zero carbon emissions and utilize a brine processing system that converts waste salt into valuable minerals for industrial use. 8. Urban sponge cities. Traditional concrete jungles exacerbate water problems by preventing natural absorption. The Sponge City Initiative represents a fundamental reimagining of urban water management. These comprehensive urban retrofits incorporate permeable pavements, bioswales, green roofs, and underground water capture systems. During heavy rainfall, rather than flooding streets, these cities absorb precipitation like a sponge, storing it for use during dry periods. China's pilot program in Wuhan has already reduced urban flooding by 80%, while providing 70% of the city's non-potable water needs. 7. Atmospheric water harvesting networks. Why rely on groundwater when moisture is all around us? Atmospheric water harvesting networks use advanced materials like metal organic frameworks and hydrogels to extract water from air, even in dry regions. With solar-powered units producing up to 10 liters daily, this low-energy technology is highly scalable, from personal use to large-scale agricultural support, offering a sustainable water solution for the future. 6. Quantum filtration technology. At the molecular level, water purification is about to experience its most significant breakthrough in decades. Quantum filtration technology utilizes engineered graphene membranes with pores so small they can filter out everything from heavy metals to pharmaceuticals. These next-generation filters require 90% less energy than conventional reverse osmosis systems while achieving superior purification results. The modular design allows for implementation at any scale, from household units to municipal facilities. Perhaps most promising is the technology's ability to remove previously unfiltered contaminants like microplastics and forever chemicals that have infiltrated water supplies worldwide. 5. Antarctic iceberg harvesting. As polar ice melts faster, engineers propose an unusual solution: harvesting icebergs before they melt and transporting them to water-stressed regions. Specialized tugboats and insulated rafts minimize loss, delivering massive freshwater supplies to coastal cities. A single iceberg can provide 20 billion gallons of water. Pilot programs linking Antarctica to Australia and South Africa show promise, turning a climate challenge into a sustainable water source. 4. Bio-inspired water infrastructure. Nature has spent billions of years perfecting water management. Now engineers are taking notes. Bio-inspired water infrastructure mimics natural systems to create hyper-efficient water collection and purification. From fog harvesting meshes based on beetle carapaces to water transport systems modeled after tree capillaries, these technologies achieve remarkable efficiency improvements. Most revolutionary is the development of living filters, engineered microbiomes that purify water using principles similar to natural wetlands. These systems require minimal maintenance and energy while providing superior resilience to environmental changes. 3. Global Aquifer Recharge Network. With groundwater depletion threatening food security worldwide, the Global Aquifer Recharge Network represents humanity's most ambitious effort to restore balance to these critical water reserves. Using advanced geological mapping, engineers identify optimal locations for managed aquifer recharge. During periods of high rainfall, excess surface water is captured and directed into underground reservoirs, replenishing supplies for dry seasons. What distinguishes this approach is its scale, connecting regions with water surpluses to those with deficits through natural underground pathways. The network aims to restore depleted aquifers across 5 continents within a single generation. 2. Neural network water management. Water management is becoming too complex for human decision-making alone. Enter neural network water management, AI systems that integrate real-time data from millions of sensors to optimize distribution and conservation. These systems monitor everything from soil moisture and weather patterns to infrastructure performance and consumption trends. By analyzing this massive dataset, they can predict shortages, prevent waste, and allocate resources optimally. Early implementations in California have already reduced agricultural water usage by 30% while maintaining crop yields. These systems promise to transform water management from reactive to predictive, saving billions of gallons annually. 1. The circular water economy. The most revolutionary water project isn't a single technology, but a complete paradigm shift in how we conceptualize water usage. The circular water economy represents a fundamental reimagining of water as a resource that is continuously recaptured, purified, and reused. This comprehensive approach integrates multiple technologies, from advanced purification systems to legislation that values water appropriately. In circular systems, wastewater becomes a resource rather than a disposal problem, with nutrients and energy extracted before ultra-pure water is returned to the supply. Singapore has pioneered this approach with its NE water system, now providing 40% of the nation's water needs through reclaimed sources. As other nations adopt similar frameworks, we're witnessing the emergence of truly sustainable water systems that can support humanity indefinitely. What do you think of our video? Let me know in the comment section below. Also, subscribe to our channel before you go. Thanks for watching.